All right. Hi, I'm David Henderson. I'm the Office Director for Fuel Cycle Research and Development. I'm presenting this on behalf of the larger office that I work in, Fuel Cycle Technologies, because this area, MS FC1, covers that entire scope, larger scope, and I have a part in that. But the reason we have this area, we've kind of referred to it as the blue sky area. Each of our programs that I'll talk about in a minute have individual program supporting areas, things that we've identified that we know we really need, really want. They've gotten more focused over the years. We recognize there's a need to allow for the opportunity for things that we couldn't think of, and the good ideas that you all might have. And so we've got this area that covers just the broader scope of our larger office, and offer it up for you to propose things that are not specifically called out in these other areas. So as such, I'm going to be providing basically a general overview of the program areas in the Office of Fuel Cycle Technologies. You would probably be well served to go back and look at some of the other presentations, any of the areas that have FC in the title, where you've got the actual program managers talking specifically, giving fuller background on their particular areas. So the mission of our office, Fuel Cycle Research and Development, is to conduct R&D broadly on sustainable fuel cycle technologies and options. We're looking at greater resource utilization, energy generation, reducing waste or the burdens of that waste, enhancing safety, and limiting proliferation risk. We do generic research and development and generic non-R&D activities related to the back end of the fuel cycle, use nuclear fuel and waste management and disposal issues. And then we are doing activities that help move the President's, the administration's strategy on the management of used nuclear fuel and high-level waste forward. So we are across the board trying to do more science-based research, a greater lower-level understanding of the fundamentals, what's really going on at a lower level that's driving some of these higher-level, macro-level behaviors. So you see a lot of that, you'll hear a lot of that in the various program areas. So this slide basically is kind of who we are and what we do. This is the nuclear fuel cycle from mining to disposal. My office, the larger office, Fuel Cycle Technologies, does R&D in every one of these areas except the reactor-specific piece that you see there in the third column from the left. However, we do develop and test fuels that go in those reactors. And then we also, across the board, make sure that the technologies that we are developing can be adequately safeguarded and protected and things like that. And then we also look at all of this as a system, because you change any of these different parts of the fuel cycle and it changes other aspects, and we try to make sure that we're not creating problems in another area while solving one. So this is kind of a similar take, but a little different and a little lower level in some cases. But again, you can see some of those interrelations that I'm talking about, particularly, like I said, the reactor group, the reactor area. We don't do research on the reactors themselves, but the fuels we definitely do the research on, with the exception of gas reactor fuels, which is another office. And then the fuel materials, cladding and things like that, have implications for other core materials, structural materials inside there. We try to balance, have a balance both of near-term and longer-term objectives. We are looking to develop solutions for today's reactors and those that are being deployed currently, dealing with the waste generated from those fuels for those reactors. But we're also looking at alternative nuclear energy systems, and particularly looking at advanced fuels for transmutation of waste and reducing that radiological burden on a repository. The material recovery and waste form development is one of the major program areas in fuel cycle technologies. In the past, we referred to this as separation and waste forms. So this is taking fuel when it comes out of the reactor and recovering the useful materials out of it so it can be reused again, also creating waste forms that are easier to deal with or give us some benefit somewhere. Advanced fuels, I've mentioned a couple of times. We're tackling this in a couple different ways. One, looking at existing light water reactors, particularly after the accident at Fukushima. We're trying to make fuels that have enhanced performance and safety characteristics, so that we make sure we're developing a fuel that is enticing to the industry to deploy as well, not just increasing burdens, but we think we can develop fuels that make an improvement there in the safety and give some performance benefit, and either keep the waste generation the same or even improve it. We're also doing the research on the transmutation fuels that I mentioned a minute ago, with an eye toward enhancing the proliferation resistance and making better use of the resource. And then we're also doing building capabilities that underpin all of this work and actually tie into others. So things like additional radiation capabilities, such as transient reactor testing in the TREAT reactor in Idaho, and post-radiation examination techniques and development there, and trying to couple all of that with advanced modeling and simulation codes. And you'll actually see in our other related area to this, that's where we're focused, is that relationship between the fuels and the codes. The Systems Analysis and Integration Group looks at how do nuclear systems come together, and how does one aspect affect the others. They finished a fuel cycle options report, screening report last year, and then they are doing additional studies off of that, and I would point you to Patricia Pavier's presentation on Monday, I think it was, that goes into a little more depth there on what they are and aren't looking for. Because she gave a very good discussion of things that aren't helpful, but there's many that might be. Material protection accounting and control technologies. This is looking at technologies for accountancy and safeguards of processes that we are developing. So let's make sure that the technologies we develop can be safeguarded, the materials can be safeguarded all the way through, and we're not developing something that really makes a greater proliferation risk. Dan Vega will be talking about some things in this area, I think, in the very next presentation. Use nuclear fuel disposition. So this is looking at the back end of the very back end of the fuel cycle. This has to do with implementing the administration strategy on dealing with used nuclear fuel and finding a permanent repository and things like that. The things here, they're focused on not finding the repository, as the administration plans to go through a consent-based licensing approach to develop and identify that. But they are looking at, eventually we will need a repository somewhere. What do we need to be looking at to make sure that we could get the fuel from where it is now to where it would need to be eventually? and this then also ties in as you look at the extended storage and transportation R&D. We're looking at what condition will the fuels and other materials be in, either in extended storage and the transportation, and making sure that we know what condition it's in and we'll be able to deal with that adequately when the time comes. So then this is the last slide, and this is the work scope description, and I will not read through it. As I described earlier, it is really a catch-all for the fuel cycle technologies area. We, as scientists and engineers, we have, largely in my office, we have just an innate understanding and feeling and sense that we can't possibly know all the things that would be of interest. We're interested in having an open area where folks can propose new and innovative ideas that we haven't specifically asked for. But at the same time, I would caution you in that, to a great degree, the things that we're really after, we've identified in those program-specific work scopes. So I would encourage you to look at our website. It's energy.gov/NE is the nuclear energy website, and then under initiatives there's fuel cycle technologies, and so that is the entire office that applies this work scope description. Look at those, understand the larger program, look at these other work scopes, and we would welcome proposals that aren't captured somewhere else. But we'll have a very high threshold for what we're looking into to fund in this area, because it is competing with some of those areas where we know we have strong needs and need to do some work. So thank you for your interest, your attention. I'll answer what questions I can at this time.
Does improving MOX fuel utilization and LWRs fit in the scope?
I think it would fit within the scope because it's not captured in one of the others. So to answer it shortly, yes.
Would advanced fuels such as inert matrix fuels be particularly appropriate for this work scope for the program in general?
I think they could along the same lines, but I mean, I would strongly encourage you again to look at the program-specific call and or the one we have with the NEAT and SUF, because in areas related to that, we really know we have some specific gaps that we want to fill, and so I'd point you toward that. But yes, I mean, it would be fair game.
If someone submits a pre-application in this work scope area and it appears better suited for another work scope, I assume a program supporting work scope area, will the program managers make that suggestion or make that move?
There's difficulties in moving projects between scope areas, especially if there's a different amount of money that's on offer. It is your responsibility to appropriately choose the work scope. You have the ability to visit with the individual program managers and the TPOCs up to the point of submission of the pre-applications. So that should clarify any questions that you have, but that responsibility is yours.